All right, 15.2, day number 1, how to solve trig equations. I'm going to skip a couple slides here. I want you to follow along with me. Trig identities, you guys, they're not going away. They're not going away. This chapter will be pretty much, I don't want to guarantee it, but I'm fairly certain that trig identities are important through this chapter, and then just a few of them are sprinkled in over the next couple. But then it's a little bit lighter on that. So you'll see identities over the next couple of chapters sprinkled in after that. Let's keep moving. Some good practice there. This is a little bit of what we did yesterday. Well, I guess we could go over this slide. If we wanted to find the solutions to both of these from 0 to 2 pi, how many times within the unit circle would the cosine be square root of 3 over 2? From 0 to 2 pi. Twice, right? The cosine would be square root of 3 over 2 here at pi over 6, and here at 11 pi over 6. What happens if I horizontally shrink that graph? Now how many solutions? 4. Let's figure out where they would be, right? On this problem here, we'd say that x would equal pi over 6 plus 2 pi k, as many times as we wanted. But we could really take the k off. You with me? I mean, we could do 0 for k and 1 for k. And we could say 11 pi over 6 plus 2 pi k. And that would get our two solutions. In this case, we are going to take 2x, set it equal to pi over 6 plus 2 pi k, and 2x, set it equal to 11 pi over 6 plus 2 pi k. So when I simplify to find x, to find my angles, what does this yield? I divide by 2. X equals pi over what? 12 plus pi k. And this one would yield, go figure, 11 pi over 12 plus pi k. Let's graph those two. Okay, so there are 2 solutions on the first one. Let's find the 4 solutions for the next one. Okay, where is pi over 12? Well, it's half of pi over 6. So there's pi over 12. And if I add pi to that, where would it end up? Chow, right there, right? That would be what? What would we call that? Pi over 12 plus pi. (13 pi over 12). Okay. Okay, 11 pi over 12 would be here. And if we add pi to that, it'd be just short of 25 pi over 12, right? 23. So that'd be 23 pi over 12. So there are your 4 solutions. And then those could go on forever if we add 2 pi k times, whatever k we want. All right, there's our 4 solutions. Okay. I'd like you to take a couple of minutes and try example 1 with a neighbor. Try example 1. Go. So the common misconception here is that students will walk into these problems and say, I'm restricted to negative pi over 2 to pi over 2. You're not. How do I know that? It says from 0 to 2 pi on both of them. All right, so I'm allowed to have solutions to this equation or to a sine function that's oscillating, and I'm allowed to have solutions between 0 and 2 pi, so like 0 and 6.28. Okay? So far, decent? All right, I think we can agree that 2 solutions to the first equation in example 1 would be x over 2 would equal pi over 6. Now, some will ask me, why do you write this 2 pi k? Well, because I don't know if it's going to generate solutions that will be within that window or not. So I just leave it there. And then I'll see in a minute whether or not it's useful. I do the same thing because there's a second solution. That solution is 5 pi over 6. I also leave the 2 pi k on there for those coterminal angles outside of the first rotation. Okay, so far so good. If I multiply both of those by 2, why would I do that? Well, so I could get rid of this 2 in the bottom so I could find the angle. What does x equal? Pi over 3. Yeah, if I multiply by 2, I get pi over 3 plus what? 4 pi k. If I add 4 pi k to anything between 0 and 2 pi, will it still be between 0 and 2 pi? No, it's gone, right? So I'm going to get rid of that. So at this point, I recognize that I didn't need it. I keep it there, but I didn't need it. Okay, I'm going to do the same thing for the next one. Multiplying by 2, you probably already see the pattern happening. I'm going to drop the 2 pi k because it's going to become 4 pi k, and x will equal, what is that, 10 pi over 6, which reduces to 5 pi over 3. Are both of those between 0 and 2 pi? Yes, solutions, done. Okay, there's 2 solutions. All right, so this graph has been stretched. All right, stretched by a factor of 2, because it's the opposite of what you think, right? I see the x over 2, I think, oh, it must be shrunk. No, on the inside, it's the opposite. Okay, the next one is really cool. All right, sometimes it's good to visualize this. If I know that the tangent is -1, where would that take place? Which quadrants? 2 and 4, right? So I'd have this -1, 1, and down here, -1, 1. So that makes these angles, well, I should really do that angle. Okay, what does that make these angles equal to? Let's call this theta 1, and let's call this theta 2 for a second. What are those? 3 pi over 4 and 7 pi over 4. Good. I don't want to call that negative pi over 4 because I want it to be between 0 and 2 pi, right? So I don't call it that. So I'm going to say that pi x over 3 equals 3 pi over 4 plus, hold on, how often does tangent cycle? 1 pi units, right? So I put plus pi k. Careful, right? It cycles every pi units. The other one will be pi x over 3 plus 7 pi over 4, whoops, equals, don't like that, equals, I do some multiplication, multiply by 3 over pi. Why would you do that? To get the x alone, that's why. Okay, if I multiply by 3 over pi, I get x. What do I get there? 9/4, right? 9/4, the pi's cancel. And I'm going to leave this just for a moment. What would I get? Plus what? 3k. Okay. Okay, I multiplied 3 over pi times pi k. I got 3k. Let's do the same thing here. I multiply by 3 over pi. Statement, what do I get? 21 over 4 plus 3k. All right, these are going to render us solutions. The first solution will be this, 9/4. What if I added 3 to 9/4? That'd be like adding 12/4 to 9/4, which is 21/4. Is 21/4 bigger than 6.28? (21/4) is another solution. I needed the k. I needed the 3k on that one. All right, so I get 9/4 and 21/4. If I go further, it's going to be past. What would this one render? 21/4. I'm going to add 12/4 to that. Is it going to be outside of the window of 0 to 2 pi? Yeah, it will be. Okay, so at this point, once you recognize that these two solutions are the same, all that you need would be to say that x equals 9/4. and 21/4. Boom shock. Let's give something a try here. I want to take you through a couple of simple ones here. This might not look simple, but I want to fire through them a little bit. You can look back at this when we're done. Yuck, gross. How am I supposed to solve that? What? Ew. I can solve it by turning it into what? Tangent? Oh. Oh, so if I divide by cosine x, and then I divide at the same time by, what is square root of 12? It's actually 2 root 3, right? Yeah? 2 root 3. What do I get? I get tangent of x equals 1 over root 3. Oh, yeah. Oh, yeah. All right, you can draw a triangle from there and make your, figure out what you're doing. Okay? Draw a triangle. All right, how about this one? What? 7-11? I don't ever see that stuff. Well, bear with me for a second. Are you with me? Are we okay? Right? Take out your calculator. And you could find yourself an angle. Yeah? I'll have to check. Would somebody do that for me quick? X equals, what'd you say, JJ? 52.57. Can I say 57.5? You okay with that? You won't scold me? Okay. All right, cool. That's calculator. This is done. Hashtag calculator. That's a calculator problem. I don't see unit circle worthy numbers there. Done? Okay, good. All right, let's get on to something that's near and dear to my heart. It's called critical thinking. All right. I'm going to skip these because these are very similar to what we just did. I want to jump into number 11 here. Ew, gross. That's yucky. What are the two angles that give me a sine of negative 1/2? It's in the 3 and 4, right? Quadrants 3 and 4. Sine is negative 1/2 at 7 pi over 6 and 11 pi over 6. So here we go. 2x minus pi over 3 equals 7 pi over 6 plus 2 pi k. 2x minus pi over 3 equals 11 pi over 6 plus 2 pi k. What do I have to do first to get x alone? Add pi over 3. So 2x would then equal, well, that's 2 pi over 6. So I'd have 9 pi over 6, which I'll reduce in a minute, plus 2 pi k. Is it asking for all possible solutions? Let's pretend like it is, okay? Because I don't want to go from this form. So then I would do what with the 2? Divide by 2. So if I divide everything by 2, let's do that like this. Oh, wow, what the heck? Divide by 2, divide by 2, divide by 2. I get x equals, that's going to be 9 pi over 12. 9 pi over 12 is 3 pi over 4 plus pi k. That'll find me half of my solutions forever, right? I do the same thing on the next one. I'm going to add pi over 3 to 11 pi over 6. That's 2 pi over 6 plus 11 pi over 6, which is 13 pi over 6 plus 2 pi k. I'm going to divide everything by 2. And it looks like I get x equals 13 pi over 12 plus pi k. Boom. There are my infinite solutions. If I wanted the solutions between 0 and some number, I'd just have to iterate using k equals 0, k equals 1, k equals 2, and then cut it off when it goes beyond whatever the end of that restriction is. All right, here we go. Oh my goodness. Which of these looks the ugliest to you? The last one, the bottom right? 16. 16 is the easiest one up here. Okay. Okay. Okay, here's the easiest one. Ready? If I flip secant over, what does it become? Cosine. What's the square root of 3/4? Square root of 3 over 2. Oh my gosh, draw a triangle. Ooh, snipe, snipe. Watch it, Marky Mark. However, if you have a restriction of 0 to 2 pi, careful, right? Oh, actually, you would still be right. So plus or minus, careful, but actually be right. As long as you made it a positive angle, right, between 0 and 2 pi. So what values would be true here? Well, x would equal, where's cosine square root of 3 over 2? Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Done. That would be your solutions between 0 and 2 pi. If you wanted them forever, you'd take each of those and add 2 pi k to the end of it. Or true, true. Okay, let's do number 24. That one tends to look filthy to children. Okay, that identity has 3 forms. Why in the world? Why would I pick this? Why would I pick that one? Because then they'd all be in terms of cosine. Okay, so you're not going to like me. What is -1 minus 2 more? Okay, and if I add 5 cosine, oh boy, we can factor this. Pause for a second. So u substitution, I want u to equal cosine of x. Therefore, I would have 2u squared plus what? 5u, that's a 5, sorry. That's a 5. Minus 3 equals 0. I think we could probably factor that together. That would be 2u and u. And I think a plus 3 and a minus 1. If I foiled that, would I get that? No, but I want a positive 5. I want a positive 5, right? So if I foiled this, I'd get 2u squared, 6u, -1u, -3. Yeah? So I'm okay. So let's rewrite this in terms of cosine. This will be our last problem of the day. Okay, so in order for this to be 0, one of these has to be 0. I could solve that. Add 1, divide by 2. Cosine x equals 1/2. Where x equals pi over 3 and 5 pi over 3. Okay, how about where does the cosine of x equal -3? Nowhere. That number, right, cosine can't be greater than 1 or less than -1. All right, so if you want your two answers between, or your answers between 0 and 2 pi, done. If the question said this, done right there. If it said all possible solutions, I'd say x is equal to pi over 3 plus 2 pi k. X is equal to 5 pi over 3 plus 2 pi k. Please be careful. Please be careful that when you're working with tan or cotan, you limit that to plus pi k. Like, subscribe, comment below, $10 gift card to GNC for the 100th sub.